Okay, welcome back. And I'm just getting again always ready. Sometimes I tap this camera and it doesn't want to play. Then it begins to play at the most awkwardest of times. Okay. Am I? I'm not here. Yeah, I'm here. Yeah, I'm good. I think I'm good. Yeah, I'm good. Right, welcome back to Terence Payne Engineering. Okay, what I want to do is to look at milling cutters. Now, I'm not a miller, so I'm not going to pretend. But what I found is that as an electrician, you will need to know of certain materials, you need to know certain cutting styles and so forth. It's part of your job because you may well be working in a milling machine or a milling factory, I should say. Okay, or working on a milling machine for that matter. Okay, so milling cutters. Tips about material. Now, all I'm going to do here is to show you, give you an idea. I'm not going to read this out to you. Okay, you can read that for yourselves, hopefully. Mild steel, etc. Alloy steel, type of steel. We have cast iron. Okay, we have brass. Okay, here. Right. And again here, this is just for you to fill recap session for you to do. Okay, no need to stand that too long. Phosphor, bronze, a free cutting but very tough material. Chips will be small and spray off the workpiece when using face mills. Okay, again, that's for you to read for Fiona Code. I don't need to read that to you. We got aluminium. Okay, magnesium alloy. Okay, that's for you to again read for yourselves. Giving you a little time to read that. We have plastics. Okay, production of surfaces. There are two ways to produce a surface on a component. Generate a surface or form a surface. Okay, and here generated surfaces are produced by the action of the cutter in combination with the transverse motion of the machine. Okay, etc, etc, etc. Just make sure that you can read that, and I've got that in play, in full play for you. Okay, fly cutting, generating a surface. Okay, and here you have concave cutting, forming a surface. Okay, cutting tooth geometry. If a milling cutter is to cut efficiently, the tooth geometry must be precise. Each tooth has specific rake angles on the cutting faces and specific clearance angles on the clearance faces. These angles are shown on the diagram, okay, in order to get an effective cut. Now, something is, make sure that if you're going to use this, that you look up the information and that you check the information I have provided against known books that you're using, etc. I do have some books, but I've put them down somewhere and I've not found them just yet, so just bear with me. Okay. Sorry about that, apologies. Okay, oh here, this is just a cutter again, but it's showing you the angles that it's cutting at in respect of the letters, okay? And this will tell you primary clearance angle, secondary clearance angle, side clearance angle, axial wake angle, okay? And radial wake angle, okay? This one here I didn't turn staggered tooth cutter with side teeth, staggered tooth cutter without side teeth, okay? Okay. Okay, hope you found this useful. Have a good day. Bye-bye.